Good afternoon. This is the official beginning of the post-lunch dip. For those that are going to be sleeping, please be at the end of the back of the room. We're not going to tolerate it. My name is Carter Bullard. I'm the session chair for our afternoon session, which is Incident Detection Using Flow. And we've got 3 great presentations for you. I think we're going to go ahead and start. People will still be filing in. But I think we're just going to go ahead and start. And the first presentation is about monitoring virtual networks from George Warnagiris. That's not even right. Warnagiris from the Teneo group. So let's welcome George.
Thanks, Carter. So before I get started today, I just wanted to give thanks to the organizers of FloCon, especially CMU, the Software Engineering Institute, CERT, Roman, Rich, Sid. Our chairs have done an excellent job. I know that this isn't easy to do, but Jonathan Spring and Michael Jacobs have really knocked it out of the park this year. This has been one of the best FloCons ever. Yeah. Good work, guys, good work. And so if you've ever heard me speak at one of these FloCons in the past, you'll know that I believe that this is one of the best security conferences out there. It's one of the unique venues where government, academia, and corporations get together and actually talk about the important issues. And really, the amount of brain power in this room is overwhelming at times, especially if you saw that last session. You can tell that people have put a lot of thought into these things. So I'm honored to be here to be able to address this group, and I hope that the work that I've done is useful to some of you out there. So my first FloCon was, so this is the 11th year of FloCon. My first was back in 2009, and as a sign of how things have changed, back in 2009 when we started these presentations, we said, okay, everybody please make sure your phone is off. Today, I'm asking everybody to please make sure their phone is on. If you log into your computer or your phone, a bunch of us have been using the hashtag FloCon 2015 at Twitter. And at Teneo Group is the handle that I am the curator of. And I think it would be great if we could get a little chatter going and maybe do some of the discussions, questions, answers, comments online instead of taking the valuable time of the presenters. So it would be great to see you guys online. If you happen to be watching this on a time shift, I will continue to monitor this hashtag and reply to any questions or comments throughout the future, probably for about the next year. Okay, so first I'm going to give a little bit of background. Then I'm going to talk into an issue I ran into. It's actually a pretty simple issue, but I think it's nice that it helps illustrate some of the points that we are going to encounter, that we've encountered, we're going to encounter in the future. And then I'll tell you what we did to solve the problem, and then discuss a little bit about what the next set of issues are going to be when it comes to this arena of monitoring virtual networks. So when the call for papers came out, I very excitedly started thinking about what am I going to present to FloCon? What can I do out of my work that would help to advance the art, would be informative for people who are attending? And virtualization came up. It's something that I've been involved with a lot for the past year, and I think that it's not discussed too much. It hasn't been discussed too much, but will be important in the future. And even though this slide is from 2011, it's the best I could find with a quick Google search, I think it illustrates the point pretty nicely that everything is going virtual now. When you go into data centers anymore, you don't see a bunch of pizza boxes, you see virtual servers that are hosting the server software. And I think that that's just advancing. I don't think that there would be any argument that to the statement that everything is going to be virtualized eventually. So another reason that I thought that this would be relevant is cloud. And as we've been going through the proceedings here, as we've been going through the week, I've conducted a bit of an informal survey of my colleagues over beers and whatnot. And I said, the question is, what does virtualization have to do with the cloud? Is virtualization the same as the cloud? And the results were pretty split. 30% agreed with me that virtualization is relevant to the cloud and maybe is the cloud. 30% said no, it's not. It's not relevant and it's different. And then 30% said, well, the cloud is just a made-up marketing buzzword, so it's not really relevant at all. So like I said, I think that virtualization in cloud virtualization is a key component of cloud. And to back up my statement, I did a little bit of research, and I came across this paper by this guy, Jonathan Spring. And in it, he talks about first of all, the first paragraph in the paper references the NIST 2009 paper on the definition of cloud. And if NIST says cloud, then it must really be a thing. The second part, as he gets into it, as you read through it, he mentions the work by the Cloud Security Alliance and their contribution to cloud academics, I guess, is to define 7 layers that have to exist within the cloud. And these are the 7. And as you can see, the network figures prominently in cloud. It's a prerequisite no matter what type of service offering you are doing in the cloud. It must include the network component, and that's the layer that I'm working at. I don't get too much into the hardware or the OS or the middleware, but I'm a network guy, and therefore I think that's important. And again, going through the academic research, I came across this paper. It's out of Berkeley by Armburst and his crew. They said that the applications delivered as services over the internet and the hardware and system software in the data centers that provide those services. So under this definition, networking is definitely a key component. Virtualization, networking, et cetera, is definitely a key component of cloud, and therefore I feel confident that the cloud is relevant to what we're talking about here today and relevant overall. But I'm not an academic. I have worked with academics in the past, and I have a lot of respect for the theoretical discussions that we've been having here, but this is my book of choice. It's by a couple of guys. I have it written down here. It's by a couple of guys out of VMware. This isn't the type of research book that builds models or discusses theories. It's actually how to use the hardware, how to use the software. And this is the kind of things that I've been doing in the last year. And I thought that maybe that hands-on kind of getting stuff done would be a good contribution that I can add here. I also wanted to reference back, in 2011, FloCon was held in Albuquerque, and our keynote speaker that year was Steve Bellovin, yeah. So it really left an impression on me, and one of the key flavors of his talk was that you need to challenge assumptions. And I think ever since then, all of the assumptions that I make, I always challenge them, and I try to see if maybe the ground has shifted under those things that we really believe. And I think that as people come up here and talk, and as we go back to work and work on these hard problems that we're doing, we have to challenge some of these assumptions. And one of those assumptions is that operations is separate from security. And in a lot of places that I've worked, that's true. But it doesn't have to be that way. Security could be integrated with operations. And I think that until you have that integration, you are going to have a hard time getting real good security. And so I'm here to tell you today, it can happen. I've worked in places where I was on the security team and I had counterparts on the operations team who I never met or didn't know. Those guys didn't even want to talk to me. And in that kind of environment, it's very difficult to actually prove that you're secure, make yourself more secure, and do those kinds of things. So I ask everybody to challenge those assumptions that ops and security are two different things. Okay, so that's a little bit of background. Here's the problem. This is pretty typical of a network, a customer network that I deal with. It's this is a physical diagram. So we basically have a big firewall sitting in the middle, and we have a bunch of machines hanging off through a switch. The virtual network is what I'm really interested, although the hardware is very important as well. So if we drill down in, you'll see that inside the virtual network, we have a bunch of machines. Pretty standard design. This is, you could think of like a hypervisor cluster that hosts machines that do different duties. And so what we would typically do is create VLANs inside of the virtual network. And so this is good. This is a segmentation where we can keep important things of different security levels separated from each other. And then we use VLANs to control the network so that it's almost like each of these subnets or each of these VLANs have their own isolated network back into the core. And so it looks like this. Again, this is the physical representation. And so we hung a couple of sensors off of the switch, and we're in good shape. We can look at almost all of the traffic going through the network. We can control it with the firewall. We can monitor it with our sensors. The problem, though, one problem with this, though, is that if there's any traffic between these machines within the VLAN or the virtual network, each one of the bubbles represented in this diagram, we don't see any of that traffic. And okay, maybe that's not a big deal. Maybe seeing all that traffic would add to our big pile and cause it to be unwieldy. But the drawback is that if an attacker were to take over one of these machines, he has free access to the rest of those without going through the monitoring process, and I'm not comfortable with that. So that's the physical look, and this is the logical look. I'm very happy with this design. Like I said, if there's any traffic between each of the segments, it gets monitored by the firewall. We can look for attacks in there. You have the classic attribute of segmentation. We're able to keep higher and lower security level machines separated. We could put users here. We can put our blueprints in another one, and we can control very tightly the access between each of those. But the problem with this diagram is the little line that connects the two sub-bubbles up in the upper left of the screen. What is that? Well, as it turns out, VMware has this nice feature that if you wanted to talk to between two clusters, you don't actually have to go through the switch. They build a nice tunnel. It's called a VXLAN, a very popular, becoming more and more popular standard. And it's a very popular standard, and the problem is that it creates a tunnel that is not seen by the firewall or by the sensors. So I thought that I would be able to get some traffic, put a sensor in between the two clusters here and take a look at what that actually looked like on the wire, but I had a little trouble with release review. So I did the next best thing, and that's mocked it up in the lab. So you probably can't, no, you definitely can't read this. But what I'm demonstrating here is that we have two machines. These are both built on a virtual machine, on a hypervisor. Each of the two machines are physically connected. They're on the same subnet, but they also have virtual interfaces in the 20/8 network range. And so when you send traffic from across between these two machines at their 20 dot addresses, they actually send it over a VXLAN tunnel. So this is what it looks like in Wireshark. And I understand you can't see this, but what this is representing is traffic between the two machines on their physical interfaces, which are in the 172.21.0 subnet. And the port being used is UDP 8472. So to me, I'm not sure what this traffic is, but if you go into the Analyze menu and select Decode As, and then choose VXLAN, now all of a sudden you can get into the tunnel, and you can see that this is actually an HTTP transaction between the 20 addresses. So I don't know if you, I hope that everybody understands what my problem is here. I have a lot of great sensors. I have a firewall, I have Bro, et cetera. I'm doing flow on these things, but when the flow record gets entered into the database, this is going to look like a bunch of UDP 8472. My firewall, which does HTTP inspection, isn't going to look at this at all. It's going to assume that it's some type of real-time UDP traffic, and it's not going to apply any of the signatures that I have. So I'm not comfortable with that either, and that's the problem that I set out to accomplish. So we did this on a few platforms. The big three that I've worked with are VMware, Hyper-V, and Vbox. I would love to get some tweets out there if anybody has other major virtual machine systems that they've run into or that they feel is widespread and deserves to be in this list. But regardless of that, these are the three that we worked with. So the sensor, we developed the sensor. This is nothing new to this crowd. It's modeled it on Security Onion. It runs Bro and does YAF with Silk. And this slide kind of doesn't make sense, probably can't read it, but the reason I put it in here is to remind me to talk about formalizing the art. If my prediction is correct that we are moving towards a virtualized world, this is an excellent way to formalize the building of sensors, and I've had a lot of really good success with it. I've built my sensor and I've refined it, I've made it exactly the way that I want, and then when I want to deploy it, I can choose what format, if I want to go onto Hyper-V or if I want to go onto VMware or whatever, I just specify the flag to say it, and boom, I can pump out 100 sensors in a few minutes, and I can put them all the way down to the level of a machine. If you look at the CERT website or the Bro website, a lot of these tools you get nowadays, the common format is ISO, so that you can build in ISO and create a machine. You can of course create a virtual machine with an ISO, but this might be another format that people would consider building. So just to get down into the weeds a little bit, on VMware, this is how you would make a VLAN accessible to a sensor. You want to make sure you go into the virtual LAN setting. I guess that's a virtual LAN, and click the promiscuous mode. Once you have that set, all the traffic would be available to your sensor. Hyper-V is a little funny. Hyper-V on 2008 is, from what I understand, I don't have a lot of experience with it, but from what I understand, it doesn't have a lot of the capabilities of doing the VLAN traffic, and you actually need to tie each machine to a physical interface on the server. So in older versions of Hyper-V, a lot of the things that we're talking about doesn't apply. The traffic doesn't stay within the contained VLAN and comes out to the physical LAN anyway. I hear that this is much improved in Server 2012, and in Server 2012, you run into the problem that I'm describing here, where some traffic is hidden from the core and from the sensor. And this is how you would do it on Vbox. Pretty simply go into the promiscuous mode and allow all, and whatever, that's the settings for your sensor. And once you click that, you'll see all the traffic from the relevant VLAN. So back to the problem again. We have a segmented zero trust network, and I wanted to mention that I like this design, I believe in this design, and I call it zero trust. That's based on the work by John Kindervag and from Forrester, and he recommends this design, and I'm a proponent of it. A couple other reasons why I'm a proponent of it, and back to challenging assumptions, and back to some of the talks that we talked about this morning. In this kind of model, you don't worry as much about private IP space, and you can actually track host patterns here. You can get down to ground truth very easily, and instead of talking very theoretically about what I can do to mathematically divine what's going on my network, I can actually look at my network. And I hear the objection out there, even though nobody's saying it, that this doesn't scale. And again, I believe that that's really an assumption that we've set in our minds, that you can't monitor at the LAN, at the campus, at the LAN. But I think you can, and I think that if your firewall, if your sensors are tuned well enough, you can take this little ecosystem, take the important things that are coming out of it and bubble those up to the top, and then you are dealing with all of the important things. And, yeah, of course, if you want to look at every single flow on every single LAN, every single broadcast and DHCP broadcast, you're going to have a problem. But if you're smart about how you tune these, if you could refine your sensor and your firewall in such a way that this is repeatable, that I can pick this up and drop it into another campus, onto another LAN, then we have something. Or maybe my assumption that we have something is wrong, and we could challenge that as well. So now, here's the final solution to what we've been doing. We actually, and again, this is a logical diagram. So now that we've set the hypervisor into promiscuous mode, we can get the packets from these individual VLANs out into the sensor, and we can do alerting and monitoring and all kinds of nice stuff. And if we do it right, we can even see the traffic that's inside of each one of these virtual LANs. How are we doing on time, Carter?
Yeah, 7.
All right, so I'm getting towards the end here. And so wanted to talk a little bit about where this is going. And again, I'll reiterate that everything is becoming virtualized. The IETF has established a working group, NV03, and they are talking about doing setting encapsulation formats for virtual networking. They've basically, the way that I would put it is that they're redoing what we did back in the days when IP and IPv6 were formed. They have a problem, you develop a group and you put out a standard and everybody follows it. I'm not involved in those standards, but I think that as a security community, we should be. I know that people in this audience do actually get involved in those, and I want to, this is my way of contributing by raising this flag and saying, hey, make sure when you build those standards, that you think about how security is involved and what we need to do to make sure that we can monitor these things and we're not just being tunneled over. The IEEE in 2014 established 3 research groups that had to do with network virtualization and software-defined networking, and they're, like someone said the other day that, standards are great. Everybody, there's so many to choose from. So the IEEE is out there doing their magic as well. We need to be involved. OpenFlow is, I think, a very interesting development, and again, software-defined networking. This is, in my opinion, the reference implementation right now. If you want to do it, you do it on OpenFlow. We need to, again, make sure that we keep these things in mind as we move forward, as we're deploying new networks, as we're deploying software-defined networks. If we're not careful, all of those sensors and taps that we've carefully placed will just be tunneled over, and we'll just be looking at a bunch of nondescript traffic that's in a tunnel and probably encrypted. And so we either need to build the hooks into the standards now, or we need to move up a level. Cisco is doing SDN. Their products are out there. You hear a lot of talk that SDN is the way of the future, but I really believe it's there now. If you look at the switches, the modern switches that you buy today, the latest, greatest that they have, they're all master-slave type setup. They do dumb forwarding and count on a smart controller to make sure they're going where they want to go. We need to build the smarts into those controllers to make sure that they're secure. Checkpoint is software-defined protection is their buzzword that they're doing. They have a product out there, and NSX is VMware's offering. They're going to virtualize the data center. And I think that this will be another big one on the roadmap, and I'm thinking that my presentation next year will be on it. So again, if this is my Twitter handle that I moderate. I would appreciate that if you found this interesting or useful or at least mildly amusing, that you would give me a follow here. And if there's any questions, I'd be happy to take them. All right, guys.
So my takeaway from George's talk is adding monitoring to the design criteria for virtual architecture is critical to the success of this stuff. So I really was excited to see George's talk on the list of things that we're going to talk about today.